Okay, so we are now going to be talking about Unit 2 review. So this is rational numbers. So Unit 2 review for rational numbers, we need to remember our sets of numbers. So an integer, integers are sets of numbers that are positives and negatives. So they're positive and negative whole numbers. So if we have a number line, there are positive and negative whole numbers on this number line. Now, if I wanted to talk about natural numbers, who remembers what size natural numbers are? What would they include? I said natural numbers are the smallest, tiniest box of numbers.
Any number from 1 to...
Perfect. So natural are 1 to positive infinity. They go on forever, but they start at number 1. They're also called our counting numbers. Okay? So the counting numbers, and that's our natural, which stands for N, natural numbers. So we have natural numbers. Okay? Now, if I include one more number on that number line, and I go backwards and I include 0. So let's say I include now this 0 with all the other numbers going to the right. What do I have?
Oh, okay. Well, then, I forget what it's called. It's a whole number.
They are whole numbers,
But
absolutely.
The second guess asking, why doesn't it go past infinity? Isn't there numbers after infinity?
No, infinity goes on forever.
What about like infinity and 1?
Well,
Infinity and
that means, yeah, it's going on forever.
Oh.
So, we include 0, they are now called whole numbers. So whole numbers are natural numbers, including 0, basically. The integers open up the rest of the number line. They open up the negative side of the number line, okay? Now, do you notice in these first sets of numbers, do I include fractions or decimals at all? No. There's no fractions or decimals in these first 3 sets of numbers. When we get into the rational numbers, that's when we get into our other sets of numbers. All right, let's move on to the rationals.
All right, I got it.
Okay, now we're talking about rational numbers. Rational numbers, they always write it this way. They said they can be in the form of m over n or a over b. All it means is they can be put into fractions. That's the biggest difference. Because when we talk about the difference between a rational number and an irrational numbers cannot be put into fractions because they're run-on decimals. Run-on decimals will not create a fraction. So, repeating numbers can be put into decimals, and so can other terminating decimal numbers. So, any number can be put into a fraction except for the run-on decimals. Now, it says any 2 integers can create a fraction, and we can change fractions into decimals. Now, any number, for example, let's say I put up the number 3. Well, I can change the number 3 into a fraction by going 3 over 1. I can also change 3 into a decimal by going 3.0. So every number can be put into a fraction or a decimal as long as it's not an irrational number. Okay? All right, let's take a look at a few more examples. So they're saying here on this first one, it's saying, notice negative 2 is an integer and a rational number. So remember when we talked about the sizes of the boxes that things could be in. How many numbers are in a smaller box? Tiny amount of numbers. Bigger box includes the smaller box of numbers and a few more numbers. Then we put those numbers in a bigger box. It includes all those other boxes of numbers and a few more. So that's what's going on with these examples. Let's take a look at a few more. So it says 2 over 3 is 0.6 as repeating. Now, repeating digits, I want to make a note about repeating digits at the bottom of this. So repeating digits always start with a denominator of 9s, then reduce. So this started out, 0.6 was repeating, started as 6 over 9, and then we reduced it to 2 over 3. So almost every repeating number starts over 9. Let's say I've got the number 0.454545 repeating, and so on. Well, that 45, how many digits are actually repeating? 2 of them. So that's how many 9s I need on the bottom. So this guy's fraction would be 45 over 99. It's always 1 less than the place value. The 5 is in the hundredth spot, so it would be 45 over 100. But because it's repeating, we subtract 1 from 100. It's over 99. Okay? That's why there's always 9s on the bottom for repeating digits. Same as if I were to do another example, if I did 0.892, and so on. If it repeats those three numbers, that means this would have been over 1,000. I subtracted 1 from 1,000, and I have 9s. I have 3 9s. Or you can remember it this way. Count how many digits are repeating. That's how many 9s you need on the bottom. So this is going to be 892 over 999. That's how it would start as a fraction and then get reduced. Okay, so that's how you always deal with repeating numbers. Now, some numbers are going to divide evenly into a whole number. So 100 divided by 45, it created an actual answer. So it started as a fraction, which is an integer, and then it solved as a natural number. Okay, a counting number, which is fine. We also have other numbers like that. So we can have, for example, let's go with 4 over 2. If I go 4 over 2, I get 2. So 4 over 2 again is a fraction, but it solves to a whole number. What about if I put square roots? This is one more thing we have to add to our bottom here. Is it says rational numbers include integers, fractions, terminating decimals, and repeating decimals. And there's one more thing rational numbers include. They include perfect squares. So, and perfect squares. Well, and if we take a look at perfect squares, if it's a perfect square and it's under a square root sign, we have to solve it. So, I should say perfect square roots. Perfect square roots. So if I've got the number 169 under a root sign, and I say, is that number rational? Well, what you might do is you always try to solve the question. So if I go into my calculator and I go square root 169, I'm going to get 13. It's a terminating decimal. It's not a run-on decimal. So that means that that number is a perfect square. So because of that, it's in the rational numbers, rational with the Q, and it's also a natural number. So because he's a natural number, if I've got those charts where I would have to tell us what kind of numbers they are, it would fall into every category except for the irrational numbers. So let's take a look at what that would look like. Push pause down, play when you're ready. Okay, so if we were to do a tick chart is what looks like this. We're just going to draw a little mini one here. So we've got natural, whole, integer, rational, and irrational is a Q with a line on top, a negative sign. Yes, and then there's an R, real numbers. But we're not going to put the R on the end because everything's a real number, right? So we would be ticking all of them. So we're going to put 3 numbers up here. So here's our numbers. I'm going to go with square root 17. So if it's got a square root sign on it, you need to make sure that you solve it. So if you solve square root 17, what do you get? You get a decimal. What kind of decimal? Does it fill your entire screen? That means it's a run-on decimal. So that is irrational. Okay, that's a non-perfect square root. Non-perfect. Okay. Now, let's take a look at the next number. So let's say we've got the number 15 over 5. 15 over 5. It's a fraction, so we know fractions automatically are in rationals. Automatically we know that. But what else do we know about those? We have to do what to fractions? Solve it to a number. Solve it to a decimal. So what does 15 divided by 5 give us? 3. It solves exactly. So if it gives us 3, we have to back ourselves up and say, well, 3 fits into the natural numbers. It's a counting number, which means it's also a whole number, which means it's also an integer. Okay? So if it's in a big box, it's going to fit into all the smaller boxes. Okay, well, I should say that. If it's in a small box, it'll fit into the bigger ones. There we go. I had it backwards. Yes?
What you say all fractions are rational numbers?
All fractions are, okay? Because fractions, if it's in fraction, that's the whole point. Irrational numbers can't be put into fraction form. So that's why fractions and decimals that end, so decimals that repeat or terminate are there, okay? So the run-ons are here because they can't be put into fractions. So the fractions have to always go into rational, okay? All right, let's take a look at the next one. Negative. No, put it aside. Negative 4 over 2. Now what's negative 4 over 2 going to give us? Well, it's a fraction. I know I see fractions here. It solves, right? It gives us an answer of negative 2. Now negative 2 is what kind of a number though? It's an integer, so it's going to go in the integer box as well. So it would be an integer and it would be a rational. Okay? All right. Well, let's move on to the next part. So we're noticing we're just identifying on the bottom. We're identifying which ones are rational and which ones are not. Okay, here's some more examples. So we got negative 1 over 4. First thing we know, fractions, so it's got to be rational. The next one, square root of 9. We get a terminating decimal, so it's an integer, and it's a whole number, and it's a natural number. So it fits into 4 boxes, the number 9. This guy, 2 negatives, cancel to give us a positive answer, but it's rational because it's a fraction, and it's a repeating decimal. Okay, so it's a fraction and a repeating decimal, that's why. We're looking at square roots here. If we take a look at D, this is a non-perfect square root. So non-perfect square roots, these three dots on the end means that number runs on forever and ever and ever and will not stop. So that's a run-on number. So non-perfect squares. Okay? Those will always be irrational. So these guys, irrational. These guys, irrational. Always, always. Okay? Then we're going to get into our fraction rules, because the whole point of this unit is to get used to dealing with fractions in every type of situation. So we need to get used to a fraction as a base number. We need to get used to fractions being used as adding, subtracting, multiplying, dividing. We got to put exponents on them. We got to do BEDMAS with them. So that's what the rest of this is about. So let's take a look at the next section. Okay, order of operations. So what we want to do is compare. Who's greater? Now remember, if you're thinking it's an alligator mouth, the alligator mouth is going to open to the bigger number. So we're going to say this 4 over 7 is greater, okay, greater than 5 over 9. It's pointing to the right, so that means greater. Now, we could solve it a couple ways. You can make this guy into a decimal and this guy into a decimal and then find out where on the number line they belong. When you find out where on the number line they belong, then that's exactly where you're going to put them, okay? And that's when you know who's going to be the smaller number and who's going to be the larger number. You're getting used to me saying that, right? Okay, so common denominators are changing to decimals. Both of them can be done the same way, okay? So whenever it's already with a common denominator, like example B, all you've got to do is take a look at the numbers. Who here, if we're looking at number 3, or negative 3 and negative 5, if we were to locate them on a number line, which is what it's showing us down here, that's what this is talking about. Well, if we've got 0 all the way on the right, we're trying to see who's closer to 0. Because whoever's closer to 0, if it's a negative number, is the bigger number. So if negative 3 is over here, negative 5 is over there. Negative 3 is closer to 0, so he's the bigger number. Okay, so that's how to remember that. Okay, let's move on to the next section. Okay, so those examples are showing the exact same thing. Okay? And again, these ones are just showing that you can put them into decimals. Those are examples of showing you to put them into decimals. What is letter G talking about? What is letter G talking about? What do you notice there? Yeah? Yeah, there's floater negatives, but what else do you notice about the floater negative?
They always float to the top.
That's right, they float to the top. But really, all we've got to do is we have to count. Are any of these going to have different answers? No. You just count the number of negative signs they have. If they've all got one negative sign, they're all going to have the same answer. So these guys are all going to have negative answers. In the final answer, your negative sign will float to the top in a final answer. But it doesn't matter where it's located to begin with. Okay? All right, let's take a look. The next section. All right, these ones you want to put in descending order. So I'm just going to, this is again terminology. What does descending order? I want you to think about a staircase right now. Descending order. Good, biggest to smallest, because you're descending, you're going down in order. So this is big to small. Okay? Now, what would the opposite be called? What is the opposite called? It starts with the letter A. Yes, it's ascending order. Good. All right, descending, like they have written down here for us, from largest to smallest, okay? And again, if they're fractions and they're comparing fractions and decimals, how do they know how to locate them? How would you know how to locate a fraction in between decimals?
Turn it into a decimal.
Right, turn it into a decimal. Well, how do we turn any fraction into a decimal?
By the top by the bottom.
You're exactly right. You actually do the function of what that divide sign, the fraction line, is a divide sign. So you take the top number, divide by the bottom. That's how you create a decimal from a fraction always. Okay. It's easier when they're in decimal form, so you can put them on the number line. All right, let's take a look. Now these guys, it says writing values in between them. Now again, when we're writing values in between numbers, if they're fractions, what could we do? We could turn it into decimals and then find it out on the number line where they are. So for this example right here on number 1, if we said negative 1/2 and negative 1/4. So if this is 0, negative 1/2 is negative 0.5, and this guy is negative 0.25. Who's closer to 0? Negative 0.25 is closer to 0. So negative 0.25 is about there. We'll put negative 0.5 right there. Now, they're saying numbers. How do you know which numbers are going to go in between these? How do you know? How do you know what numbers would go in between there? Look at the two numbers, okay, that are right after the decimal place. You have a 5 and a 2. What numbers are in between 5 and 2? 3 and 4. So you can take negative 0.3 or negative 0.4. They're going to be in between those numbers. So always take a look at the number right after the decimal place, and then choose the numbers in between it. That's how you can find them if you're looking for that. Okay? Now, what if the numbers are really, really close? 0.25 and 0.26. Well, when they're that close, you have to add a third digit. You have to add the other digit that would be between those. So, if I wanted on my number line, and I'm going from 0.25 to 0.26, well, I've got all kinds of choices. I've got negative 0.251, negative 0.252, negative 0.253, all the way. So all of these numbers here are going to go 1 to 9. So you're going to add the numbers 1 to 9 after the smallest number. So the smallest number between 5 and 6 is a 5. So you're going to add, after the 5, a 1 all the way to 9. And those are going to be the 9 numbers that are in between there. So you've got 9 choices. And again, all you're doing is putting numbers after them. Okay? All right. Let's take a look at number 2. identifying fractions between. Again, a good idea. Try to change your fractions to decimals. That's a good way to do it, okay? Try getting used to turning your fractions into decimals. Alrighty. Adding rational numbers. Like all of the rules for all of these are in here. So I'm just going to briefly go over this so we can go into Unit 3. So, adding integers, these are just positive and negative numbers. You need to know where they are on the number line. And most of it you can do with a calculator, but you will have a section of 20 questions without a calculator. Okay? So, whenever you've got negative and positive numbers, literally draw yourself a number line. And that will help you. Okay? That will really help you on the non-calculator part. Draw number lines if you have to. Okay. The next one, same idea here. You're adding negative numbers. If they're both numbers that are negative, literally just add the digits and put the negative sign back on.
Is there a short answer on the page?
No. So there's only numeric response and multiple choice and your non-calculator portion. The non-calculator portion is all numeric response, 20 numeric response. Yeah. And the non-calculator part can also be negative. Whereas before, remember on all of our unit tests that you wrote this year, if you got a negative answer for a numeric response, you did it wrong because it couldn't be negative answers. Well, now they've let us do negative answers. And what they've done now, because on the top of the PAT sheet, what they've got is this. They've got, you know how they usually have the decimal up here? Because the decimal can be in a couple different spaces, and then they've got the numbers 1 all the way to 9, and then sometimes they put 0 at the top or at the bottom. Well, now they've got a circle there now with a negative sign that you can bubble in. So if it's a negative answer, you bubble in the first one that it's a negative answer. So they've got extra options there for you. And that's okay. It just gives you an extra way to do. Okay? Just needs more practice. So again, like I said, use number lines if you have to. The good thing with negative and positive numbers, when you're adding in, especially when you're adding them, think about money. Because if you think about negative numbers as money that people owe you, you can easily figure out how much people owe you. Okay? People are pretty good at doing that. So think about money. Okay. So we're going to go through adding decimals, same idea. If we want to add a decimal, we line the decimals up. So if it's a non-calculator portion, what we would do is this. If there's negative and positive numbers, use a number line for sure. But let's say they're both positive numbers. Let's say I'm going from 1.2 and I'm adding 2.7. Well, literally just line them up where their decimal is vertically. So I would take that question, I would say 1.2, then I would line up the decimal number, then I'd have a 7 there and a 2 there. And then literally add straight up and down. So put your decimal, the 2 and the 7 add to make a 9, 1 and 2 add to make a 3. Okay, so that can help you with your non-calculator portion. Just line the decimals up, okay? Now what if, let's just pretend the 7 had a 3 at the end. What would happen to that 3? There's no number here. So we would just put a 0 or remember that there's nothing there. If there's nothing there, this 3 is going to come down by himself and just sit there anyway. Okay, because he's adding to 0. Okay? All right, let's move on to the next one. Okay, so again, those are adding positives and negatives. The answers are there for you to try the practice questions. Now, adding fractions. Adding fractions, you need a common denominator. That is the most important thing. So, I want you all to circle or highlight common denominator. Now, once you've got your common denominator, all you're going to do is you're going to add the numerators, the top. You're not going to do anything to the bottom will stay the same. Then, in the very end, your last step is always reduce. So we need to make a note here, always reduce if possible. Okay, so we always have to reduce if possible. Now, we can do common denominators. What's one strategy of common denominators we learned this year?
Oh.
How can we find bottom numbers?
Make I forget what it's called, but like you times them like by themselves.
You're talking about a skip count list.
Yeah,
Lyle,
skip
you're
count.
exactly right. So, skip count list. Okay, skip count lists help you find the same bottom numbers. So what you would do is I would take each number and I would times by 1, by 2, by 3, by 4, and make a list. So if I start with my number 8, I would times it by 1 and I get 8. I'd times it by 2 and I would get 60. I'd times it by 3, meaning I times the 8 by 3. Okay, 8 by 1, 8 by 2. And then I'm going to get 24 and so on. Then I do the same thing for the digit 4. The digit 4, I'm going to multiply it by 1, and I'm going to get 4. Then I'm going to times it by 2, and I'm going to get 8. And then I'm going to times it by 3. Oh, I get 12, but I can stop already. I found my answer, 8. Okay? So the skip count list can help you find the common denominator much quicker than just multiplying the bottoms. Okay? All right. I'll let you write that down.
Oh, I already got
Okay. So let's move on to the bottom now. Again, those are examples for you to try. Now, we've got in mixed numbers. Mixed numbers we never deal with. What we do is we change them to improper fractions always. And your lowest answer is always an improper fraction, not a mixed number, unless the question's asking you for a mixed number. Okay, so that's what's going on with that one there. Okay, so again, our last step here, if we look at the 4 stars, always reduce our fraction to lowest terms. Then you've got some practice questions with the answers. Now, word problems. Word problems, again, typically you're just going to be adding, subtracting, multiplying, or dividing some type of a fraction. You're going to be doing some type of FedMaths. Okay? I'll let you have a chance to look through those. They've got the answers with you, and then practice questions with the answers. Subtracting rational numbers. Same steps as adding. Nothing changes. Only this time you're going to subtract the digits instead of add them. So nothing changes. Same thing with fractions. All of the rules still apply. So nothing changes there. Those are your practice questions. Subtracting word problems. They typically deal with temperature for word problems. Okay, so those are for you to try. Now, multiplying rational numbers. The beauty about multiplying rational numbers is when, again, we count the number in negative signs when we multiply and divide. An odd number of negative signs gives you a negative answer. An even number of negative signs gives you a even number, is positive answer. Okay, so multiplying rationals. Literally just multiply the digits. What if they're fractions though, or decimals? When we multiply decimals, you literally just multiply a decimal. Okay? Now, let's take a look. Those are practice questions. I want to talk about the fractions here. So multiplying fractions. The rule is we multiply straight across tops, straight across bottoms. So you're going to notice with the fraction example, they're multiplying tops, multiplying bottoms. But again, you're going to notice they put this negative sign, they floated to the top. There's only one negative sign, so our answer is negative. Now, our final step for this is to make sure that we reduce. Both of them are even numbers, so we start dividing by 2. And if we can divide lower, we do. Okay? If it's a mixed number, we need to change them to improper first before we can start. Okay? Those are big hints. We need to change those before we can start. Okay. So there's lots of practice examples for you here to try. Tons and tons of practice examples. So, literally flipping through these. That's why I'm just flipping through. Dividing. There is something special about dividing when it comes to fractions. So we're going to skip down to the dividing fraction rules. So what's different when we divide fractions? Do we actually divide fractions? We never divide fractions. We flip and times. Yeah, we flip, and how do we know which one to flip? Good. We always flip the one that comes after the divide sign, okay? He's the one that's going to flip upside down. So this guy flips upside down, okay? And then when we flip it upside down, we change the divide to a multiply. Okay? We change it to multiplying every time. Okay, the rest of the examples are for you to try. They've got the examples worked out on there for you on purpose. These are excellent problems for you to go through. The last step is to go through BEDMAS. So BEDMAS and order of operations. And exactly, it's got some examples. Now with multiplying and dividing, same as addition and subtraction. You do it whichever comes first, left to right. Just like you read a book, you start left and go to the right. Okay? It's whichever comes first, what you do first. So the rest of them are for you to do on your own. This is practice for you. You're going to now switch into Unit 3 in a moment. One more thing we have to remember is we're going to always have to solve an error question. A kid made a mistake doing the question, where was the mistake, and then go fix it. Okay? So you have to be able to identify those. So when you're doing these questions, cover the answer up and then try and solve it yourself. That's the best way. So, for example, I would do the question right here, right beside it, and then I would solve my answer, and then I would compare every step, and I would try and see where they went wrong over on the left. And I would circle where they made the mistake. Okay?
Yeah, I have like 5 minutes.
Yep. Okay. So, okay, there's more practice questions, and that's a wrap. So, this concludes our review for Unit 2 Rational Numbers.